Okay, we have this question on indices and logarithms to do here. We start off by looking at 2x cubed to the minus 5 plus 2x minus 3, and we want to write it in this form. So first of all, we want to get rid of these negative powers, and then we want to write it as a single fraction. So let's get rid of the negative powers first. So multiplying out this brackets, we have 2 to the minus 5 and x cubed to the minus 5. And 2 to the minus 5, we're just going to write that out like this. And then we've got x to the 3 times the minus 5. We multiply the indices. And then we're just going to write plus 2 over x cubed. That deals with the minus 3 here. So that's x to the minus 15. So that means the x over 15 is going to be x over 15. 2 to the minus 5. So we're going to have, that's going to be 1 over 32. 32 times x 15, 1 over x to the 15 plus 2 over x cubed. And we want to write it all as over 2ax and ax to the 15. Well, let's just keep going. So we've got x to the 15, and at the moment we've got 32x to the 15 on the bottom. So if we write 32x to 15, we don't actually have to times top and bottom of this by anything to make it the same. Yeah, the bottom is the same. We're going to times the bottom of this by x to the 12, and we're also going to times it by 32. So we're going to times the top by 32 and x to the 12 as well. So 32 times 2 times x to 12. So we can see that a is going to be 32 in this case. So better written as 64x. If we were to write it out as one fraction, it's better written like this. And obviously a is going to be equal to 32. Right, in this question, which of the following statements about log AB equals C is correct? C can be negative. It can. If you draw a sketch of a log curve, it looks like this. So the log of A, B, or C can be negative, which is all the way down here. B, so that's okay. B must be greater than 0. You cannot do log of a negative value. If you notice, there are no values this side of the graph in our logarithmic graph. So B must be greater than 0. That's also true. A value of A must be smaller than the value of B. And that is not true. Okay, we could do log to the base 10 of 2. That's quite perfectly okay. That is not true. Okay, so that's probably the one that's incorrect. The expression can be written as B equals A to C. Well, the way I like to do it is if we got log A of B equals C, then we raise both sides to the power of the base, and that will undo the logarithm. Like that. And that undoes the logarithm, so that means that B equals A to the C, and that's true. So the one that's not true is number 3. Okay, we want to write this expression in this form where it's just powers of 3. So let's have a go at that. So if we do this first, we've got 3 to the x minus 5, which is the same as 3 to the x times by 3 to the minus 5. And 81, 3 to the power of 1 is 3, then 2 is 9, cubed is 27, and to the power of 4 is 81. So we've got 3 to the power of 4. Now, 3 to the minus 5 means 3 over the power of 5, which we got there. So we've got 3 to the x over 3 to the power of 5 minus 3 to the 4. Now, if we want to put this over the power of 5, at the moment it's just over 1. So therefore we must times top and bottom by 3 to the 5. So that gives us 3 to the x over 3 to the 5 minus 3 to the 9 over 3 to the 5, because if we times this by 3 to the 5 here and times by 3 to the 5 here, what we must do here is we must add the indices to get 3 to the 9. So our final answer is going to be 3 to the x minus 3 to the 9 all over 3 to the 5. Then we have it in the format that we have here.